Alrighty. Should be streaming. Yeah. Let's figure it out. Oh, okay, alright. This is the wrong title. How do I change the title? Ah, okay. Okay, we are figuring it out. Wonderful. Okay. Heck yeah. Let's reload the page. Awesome. Okay. Perfect, amazing, wonderful. Let's get started. Okay, so hello. I'm Adrian, also Avatar Lilith. This is my second live stream at Laboratory Residency. I made a cute little outline of what I'm going to go over. There was a lot that I wanted to fit in, but including my PC build. But I think I'm going to make a video of how to put together a PC because I recorded my process and I basically just recorded my entire PC setup, but I think there's not enough time to go over that whole thing today. I was also planning on like drawing out a little bit of chart of like how a computer works. So if that's something that people would like to see, definitely let me know. So yeah, hold on, let me turn this other thing off. Oh yeah, hi, hey. Okay. Cool. I can see a chat. This is weird. I'm like experiencing Earth for the first time. Okay. Wonderful. All right, so what I'm gonna go over in this stream is my PC, what a 3D object is, and I'm gonna talk about my pipeline, which is from Blender to ZBrush, then to Unity, and sometimes I go back and forth. And then I'm gonna give a little bit of an update with my manifesto. So I built my computer. This is something that I never really thought I would be able to do. It was a little bit of a daunting task at first, but I honestly just like I did a little bit of research and I became a little bit comfortable with the components, and I watched a couple YouTube video builds of just like other people building their own computers, and y'all, it is really just adult Legos. It was really easy. There's manuals that you might have to check, but the way that I went about it was I would highly recommend looking at the websites of the software that you're going to be using. So for me, I looked at the Blender website, I looked at the Unity website, and also the ZBrush website. And on those websites, they have their spec requirements. So they have their like bare minimum requirements, which is what I was using for my old build, which was severely underwhelming. And then they usually have like optimal specs for what you want to be using, and it's all there. And then you can like research you can basically determine what you need based off of the software that you're going to be using, and also specifically what you're going to be doing with that particular software, if that makes sense. So for me, I'm doing a lot of 3D modeling, I'm doing a lot of rendering, I'm doing a lot of things that are affected by by the viewport. So that's, you know, Blender, a lot of it is moving around in this space, which is very CPU heavy. So for that reason, I wanted to do a Ryzen 9 3900X, which was absolutely phenomenal. Here, I'll show you. So if you're not familiar with the parts, that is okay. What I can do is, if people are interested, I would be more than happy to make a video, just very, very basics of like, what is computer? This case is my most favorite thing about this, honestly. It's the Fractal Design Meshify case. It's got like a really beautiful geometric side panel and also tempered glass, and it has a really convenient little magnetic dust cover, which is awesome. And so back to the CPU. This little fan here is the fan that came with my CPU. I didn't know that. I didn't know that the Ryzen came with its own fan, so I actually bought like a Corsair, some RGB, fancy lighting fans. But so this came with it. Here are my 2 sticks of RAM. I have 16 gigs of RAM. That's probably what you're going to want to use. 8 gigs is, I would say, the minimum. ZBrush is like 8 gigs minimum, but you should get 16 gigs of RAM. You can customize these lights depending on the temperature of your CPU. Isn't that, or no, of your GPU. Isn't that nuts? That's, yeah. So I love this child. It took me a few hours. I took my time with it. I just wanted to make sure I was getting everything right. Just do it. Like, I'm not a computer guy. I'm also not a Lego guy. I put the round peg into the square hole very often, and I was able to do this. So I highly recommend the process of researching the parts that you need based off of the software websites, like the software that you're using, and just like watching YouTube videos of what is a computer and like how do the parts interact. I was planning on drawing a chart like real time for this stream, but I think that I will save that for, oh, yeah. Oh, I'm sorry, I haven't been checking the comments. How do I do this? Yeah, you should totally build your computer. It's like, just do it. And it also like gives you more confidence to be able to tinker with other types of hardware, which is kind of nice. Okay, so the power supply, I got 750 watts. I think that's probably optimal in case I wanted to upgrade anything. Right, 16 gigs of RAM. My GPU is a 1060. I was running on a 1050, an NVIDIA 1060. I was running on a 1050 Ti for my old build, which was really just basic. The 1060 was sitting on my desk for a year because the first computer that I bought, I didn't build it, and I didn't do enough research to make an educated purchase. I thought I would just be able to interchange the parts and just like switch everything out. But turns out it was like a proprietary build, so it was like HP, and some of the things were not very functional in terms of customization. So the motherboard didn't have the correct socket for the Ryzen, the CPU that I was using. And it also like didn't have any cables that I would be able to use for the power supply. Also the power supply didn't have enough wattage. So just do a little bit of research about compatibility if that is something that you want to do in the future with like switching parts out. Ryzen, I think AMD is really great because they made this commitment to keep the sockets the same on the motherboard so that you would be able to upgrade your CPUs or whatever else you want to upgrade. Yeah, what else? And I also was not using a solid state drive before. So this is like, you know, like when you're blind or like you don't have good vision and then someone hands you glasses and they're like, look through this, this is what the world is like. That's kind of like what this is. I've only been running it for a couple days, but already, I mean, I can live stream, like it's nuts. So yeah, I highly recommend doing your own build. I also took my hard drive from my old computer and I stuck it in here for extra storage space, and also to like switch everything on there. I had to get Windows, which sucks, but whatever. All right. Motherboard is like a Gigabyte B550. It's just like a standard motherboard. It has pretty colors, but you can't really see it in here. So this is my child. I love her with all my heart. And please let me know if you would like me to go over like a really basic video of how the computer parts work. I would be down to do that. So let me know if that's something that you want to do. I like recorded the whole thing, so. Okay, so next thing is, next order of business. I'm gonna talk about what I do. I sort of went over it for my first live stream, but I sort of wanted to get into the nitty gritty of my pipeline because it seems like there's this incongruity of like the things that I have on the screen and how to actually get there. So I'll just go over like what a 3D model is. A 3D model is basically, it's basically a series of coordinate points. So here you can see all of these little, here let me actually go into edit mode. Well, not that. Well, okay, this is a 3D model. It's basically a collection of data points that tell the computer how to simulate surfaces or objects or basically anything within the provided 3D software engine. So the way that you build a 3D model is from vertices that combine to make a mesh. So all this is a mesh. All of these are different 3D objects that I'm selecting on, and they're all created from a mesh which contain data points that tell the computer how to render the surfaces of this model. So you can see here that it's a pretty dense mesh. The way that people usually start off is from basic to more, from like a low poly mesh to a larger poly mesh. And poly is just like basically the shapes that comprise the mesh. So when you're saying low poly, it just means that there's less shapes, and high poly means that there's more shapes, so more details. All right. I know it looks a little wonky right now. Let's these. Okay. So what I just changed in the viewport is just the type of view that you can have for your 3D model. None of this is being rendered, so none of it is being computed. There's no computation right now happening on how the computer is going to display the surfaces of the model when you're done with your like finished product. This is just like a solid viewport that makes it easy to navigate around the screen. So when it's being rendered, you can see the difference there, where it's highly realistic, and this is using a rendering engine. So all of the stuff with the viewport, that was using the CPU, but what you can do is you can allocate the rendering to your GPU, which is basically the functionality of facilitating images on your screen. So the way that I made this is, let's just, all right. So the way you create a mesh is you have to start really simple. So what I did is I just created a circle. It's just like a mesh of that looks like a circle. Here, let's see what I can do. So for example, I don't know, let's say you wanted to make an eyeball. So you can move these points around. You can see this, right? You can move these points around and manipulate these vertices real time in 3D space. So what I'm going to do here is like, okay, well, let's say that we want that to be an eye. I'll just like bring it up here. And what we can do here, now that we have our edge loop, this is called an edge loop. I think I might be getting a little bit too technical, but I'll try and breeze through this. What you can do is you can extrude points from the mesh to create surfaces. So what I'm doing here, I'm just extruding and extruding. See, I don't know if that can help elucidate these concepts, but yeah, I mean, it's really just, you want to start off with the most simple mesh possible, and then you can always subdivide. So when you subdivide something, what it does, it upgraded, so I don't actually remember all the commands. So let's just add a modifier, subdivision surface. So you can see that basically doubled the amount of polygons on this surface. You can shade it smooth to make it look pretty. Yeah, sorry, that looked really weird. So this is a 3D model, and this program is called Blender. Blender is an amazing tool that lets you do all this crazy stuff, and you can actually export animation and different physics simulations, and the fact that you can 3D model and you can also sculpt in this program is pretty fantastic. So the way that I use my pipeline is I will construct a base mesh with a very, very low poly model, and then I will take that mesh and then I will import it into ZBrush, which is, oh, where's ZBrush? Here we go. So I don't know if you remembered what I was talking about with the mesh, but you can see that these edges on this model are basically, it's just, I exported the 3D model into this other software so I can continue working and sculpting to refine the details. So the way that ZBrush works, Blender can actually do the same thing, but ZBrush is a really, really good tool for this specifically. You can sculpt like you would in real life. So, for example, let's just like make a subtool. Yeah. So the way that I work is I maintain the mesh structure of this 3D model from Blender, and I manipulate it in ZBrush however I want to. So I know it looks a little funky. And from here you can watch while I subdivide it. You see that we're getting way more refined in these details. So ZBrush lets you have an extremely high poly model that lets you get really, really detailed. So I don't know if you can see these pores and stuff. But anyway, and what you can also do is you can paint on the model, which is how I was able to create the skin textures. Where's paint? Yeah. Isn't this fun, guys? Okay. And what you do with the texture painting is you can export it as a map, as a texture map. This is a texture map. And then you can import it into other types of 3D softwares. So the next step after, what am I on time? 4:30. Okay. All right. So the next step after ZBrush is I will take this 3D model, I will export it, and I will bring it into Unity. And Unity is a game engine. Unity is great. It's really just an amazing tool that lets you write scripts. It lets you, you can do like 2D games, you can do 3D games, and it allows you to like import your 3D models and code in interactions, which is what I did here. So I basically just took the head and I was using it as a test to test my motion capture system. So my motion capture system I'm live streaming from my Kinect, which is a depth sensor, and it creates a skeleton rig and feeds in that information through Open Sound Control into my program. Open Sound Control is basically just data points that are being sent over a network. So each coordinate point of, like let's say my hand, it'll be able to take that coordinate point and shoot that over the network in real time and spit it out into Unity. So I can use those coordinates to control my mesh. So that's basically how this works. So the cool part is, start sensor. I'm using a plugin that if you want any info on, I can get it to you. It's free. I really believe in using open source and free software. I don't believe in depending on for like Facebook's software, which would make this a lot easier, but I'm not going to do that. So, hello. Let's start this bad boy. So this is just my scene. I'm moving around in the viewport, and this is being rendered live. So it's using a combination of the CPU and the GPU. Hello. Let's see. So this handy, nifty little plugin, you don't have to use this one. You can use any plugin that spits out Kinect data into Open Sound Control. So when I open my mouth, it opens the mouth of my model, and here we can see that my 3D model is being moved in the viewport, and let me open up that texture map. So I don't know if you remember the texture map that I was talking about before, but what you can do is you can import the model and then you can apply that texture map to the model so it can render the surfaces accordingly with how you constructed it in your 3D modeling software. Okay, Blender to ZBrush to Unity. That's my pipeline. There are sometimes some compatibility issues, but I think it's really good for the work that I'm doing. And I have not yet combined the body movements. I should have done a demo where I was, I have the ability to manipulate my model according to my body, but I don't have that project pulled up here. So hopefully for next week, I will be able to attach the head to the body. Okay. How am I on time? All right, I think I got a few more minutes. I feel like that explanation might not have been the most coherent. I would be more than happy to make short little videos that maybe have a little bit of a better structure, and also that can go a little bit more into depth with how all this stuff actually works. So let me try and think of anything else. All right, I'm gonna stop this. Okay. Well, so that's that for my pipeline. So my manifesto, here we go. All right, so I'm working on a research paper that basically outlines the power dynamics and sort of the issues and biases and conflicts with 3D models and the future of virtual avatars within the constraints of surveillance capitalism. The research paper is part of the manifesto, but what I did here is I narrowed down my manifesto into 5 basic pillars. And these 5 pillars are under the categories of, I would say like there's 4 main categories. I actually have a map that I can show you. I've been working out this this little map, and I'll probably put it up there on the web, on the interwebs, when I'm done making a little bit prettier. So these 5 pillars, they sort of live under the umbrellas of these 4 main headings of surveillance, bias, knowledge, and control. And I'm not going to read through these right now, but you can feel free to go on my website, ethercomplex.com. This is like the basic structure of how I'm going to organize my manifesto. I'm trying to work on making it a little bit more accessible. Sorry, my hand is like touching my computer. Get off my face. My draft right now has pretty heavy technical language, so I'm working on making it accessible to people who have no idea what like 3D stuff is ever. So that's, I think, basically it. I don't know what my timing is like. I didn't know when I started. So right now I'm just gonna open it up to questions. If anybody has anything, I'll wait a moment, and if I don't receive any questions, I will stop the live stream. I forgot to do that last time. I think I'm seeing everything. Huh, wait, how do I see the comments? Okay. All right. Okay. Cool. Well, if nobody has any questions, I'm going to stop the stream. If you want to contact me, you can reach out through my Instagram. You can message me on my website. There's ethercomplex.com. There's also adriancassell.com. I also have my performance website, which is lilith.com. And all of those have emails where you can contact me. So yeah, well, thank you everyone for tuning in. Hopefully I covered everything, and hopefully I didn't go too much over the time. In conclusion, build your PC. This case is actually really incredible. But yeah, just like go for it. Like I just want to reiterate how much of a non-computer, non-hardware person I am. If I just want to be able to say if I can do it, you can do it. I feel like there's a lot of like internet hurdles that make it seem a little bit inaccessible and a little bit of kind of like a dudes club, and hopefully I can provide a platform for anyone who has any questions about like what all this stuff is and like how to do it. I am an extremely non-hardware oriented person, so yeah. All right, so I think that's going to be the end of this stream. Thank you for tuning in. I'm Adrian. I'm also Avatar Lilith. Yeah, tune in next time. Be sure to watch all of the other resident artist streams. And yeah, I'll catch you on the flip. Oh my gosh, I can't believe I said that. Okay, bye. How do I end this stream? Oh.